So we are back with the problem solving in momentum and impulse. So we'll use the past papers so that we can align our teaching so that we meet the cognitive demand in the section. So first question here is drawn from one of the past papers. It was talking about the dancer here. They say dancers have to learn many skills, including how to land correctly. A dancer of mass 50 kilogram leaps into the air and lands feet first on the ground. She lands on the ground with a velocity of 5 meters per second. As she lands, the velocity of 5 meters per second will be the initial velocity. 5 meters per second. As she lands, she bends her knees and comes to a complete stop in 2 seconds. Now delta t is 0.2 seconds. Fine. And comes to a stoppage, means that the final velocity is 0. That's what we are told in brief. This is the case. Now let's see. The mass of the dancer, that's what is given. Mass of the dancer is 50 kilogram. That is very important in momentum. The first question, calculate the momentum with which the dancer reaches the ground. Calculate the initial momentum of the dancer, in other words. Therefore, that is 1.1. With this, we'll know, oh fine, the initial momentum of the dancer will be mv. Mass of the dancer is 50. The initial velocity of the dancer is 5. Remember, the dancer was going down, therefore this 5 meters per second is down. Then we multiply, we get 250 kilogram meters per second down. We are dealing with a vector. Don't forget that. So that is the initial momentum of the dancer. Let's continue and find out what else do we need to calculate in 1.2. Now they are saying to us in 1.2 we are not calculating, but we are defining. Define the term impulse. Define the term impulse. Now what is impulse? Remember, when we define impulse, we are using that formula of F net delta t. Therefore, it means that the definition of impulse will be now the net force. Will be the net force acting on an object. The product, sorry. Let me start properly.